Hello, folks. Welcome to the last video in the Exponent and Powers video series. In this video, we're going to have kind of a 2-for-1. We got exponents, a second set of exponent laws. So we're going to talk about those now. So when I have a power to a power, so for example, 2 to the 3, and then I take that 2 to the 3 and I put it to the power of 2, right? We call this a power of a power because that's what's happening, right? We simply just take the 2 to the 3, we put it to the power of 2. And there's a couple of ways that I could deal with this, right? Like I could do order of operations, which tells me to do the inside of my bracket first. So 2 to the 3 is 8, right? So this thing becomes 8 to the power 2, which is 64. So that's not the only way to deal with this question, 2 to the 3 and then to the 2. We could think about it like the repeated multiplication that we've been dealing with in as a part of this whole kind of series, right? We understand that powers are repeated multiplication. So 2 to the 3 to the power 2 can be thought of as 2 to the 3 times 2 to the 3, right? Because that's what it means to square something. It means to multiply it by itself. And in the last video, we actually learned how to deal with a question like this. 2 to the 3 times 2 to the 3 is 2 to the 3 plus 3. Well, 3 plus 3 is, if we're kind of thinking all the way back to our earlier math years, 3 plus 3 is a multiplication. That's actually 2 times 3. So this thing is 2 to the 2 times 3. Now, notice where I started and where I ended. So we have 2 to the power 3 to the 2 becomes 2 to the 2 times 3. And in fact, that's actually one of our rules when we're talking about powers and these types of powers. Whenever I have a power to a power, I can actually simply just multiply those two exponents together to find a new power to give me the same result. And if I did 2 to the 6 in a calculator, what I would find is that I would still get the answer 64. Okay? The other rule that we're talking about is the power of a product. So we've looked at the product of powers. So if I have something like 2 cubed times 2 to the 4, we know that we can take that product of powers and we can, because they have the same base, we can simply just add their exponents. So now instead of looking at a product of powers, we're looking at we're looking at a power of a product. So taking a product and putting it to a power. So again, just like with any other power, we can kind of understand what's happening here by writing it out as a repeated multiplication. So 2 to the 3, 2 times 3 to the power 4 is 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3, right? 1, 2, 3, 4 of them. But again, because this is just a string of multiplications, the brackets aren't actually doing anything. So this is 2 times 3 times 2 times 3 times 2 times 3 times 2 times 3. And again, because this is a string of multiplications, the order in which we do them also doesn't really matter. So I could do 2 times 3 and then 2 times 3, or I could take all of the 2's and I could multiply those together. Right? So I could say this is 2 times 2 times 2 times 2. And then I could take all of the 3's and I could multiply those together. So we get times 3 times 3 times 3 times 3. So instead of looking for the answer, what I'm doing right now is I'm just kind of manipulating and rearranging to see what I get. And what we find is that if I take these 2's and I think about them as a power, I get 2 to the 4. And if I take these 3's and I think about them as a power, I get 3 to the 4. So what that means is if I have 2 times 3 to the power 4, unlike with addition, if I had 2 plus 3 to the power 4, that doesn't get expanded. There's nothing we can do with that. It's simply just use your order of operations. But 2 times 3 to the power 4, that actually turns into 2 to the 4 times 3 to the 4. So something that may make doing a multiplication easier or harder, or depending on what we're doing, if we're working in next year and we start talking about variables and putting those to powers, just making sure that things simplify properly. It's really important that we understand this is how this works. So if I wanted to say take questions like this and take a power to a power and simplify it, right? Notice it says to simplify or to write as a power, one singular power. All we have to do is take the exponents and multiply. So -7 times 3 to the 2 becomes negative 7 to the power of 3 times 2, which is negative 7 to the power of 6. Negative inside my bracket, negative not inside my bracket. So negative 2 to the 4 to the 5 becomes the negative of 2 to the 4 times 5, which is the negative of 2, to the power 20. And then finally, 6 to the 2 to the 7 becomes 6 to the 2 times 7, which is 6 to the 14. Perfect. If I wanted to do the same thing as the product of powers, or a power of a product, we can do the same thing with a quotient. In much the same way as the last video, we were talking about how products and quotients, or products and divisions, kind of are the same operation, essentially. So the rules apply much the same way. Well, the same thing is true here. If I took 5 times 6 and I put that to the power of 3, I can think about that as 5 to the power of 3 times 6 to the power of 3. Well, 5 divided by 6 to the power of 3 works much the same way. So 5 divided by 6 to the power of 3 becomes 5 to the power of 3 divided by 6 to the power of 3. Okay, so if I wanted to, say, write these out as a quotient, as something expanded, then I can do that by simply just putting each piece to that power. I'm not going to do the whole thing, but let's do a couple of them. So if I want to do 21 divided by 5 to the power of 4, well, that is 21 to the power of 4 divided by 5 to the power of 4. If I wanted to do 1 over 3 squared, well, that becomes 1 squared over 3 squared. Okay. Now, if I wanted to, say, evaluate these things, right, there are different ways that we can do that. So be really careful about when these questions are, how they're worded and what they're asking you to do. So in this example back here, it said just to write it as a single power. Don't do anything with that power, just write it as the power. But with these questions, it's now saying to evaluate. So depending on how you want to evaluate, you may find that it could be easier to do your order of operations. So to perform this multiplication, so to do negative 7 times 5 first, and then take that answer and square it, right? So negative 7 times 5 is negative 35, and then I can square that. But you may find that maybe negative 35 is something you're not comfortable squaring, right? You're not sure how to square negative 35 in your head. Maybe you have to grab a calculator. But maybe you can do negative 7 squared and 5 squared and do that multiplication, right? So we get 1,225 if I do it this way. Or if I take this and I expand it, then using our rules we just determined, so we get negative 7 squared times 5 squared. So that's negative 49. Sorry, not negative 49, positive 49 times 25, right? At this point, we could hopefully do that multiplication. And if we did do that multiplication, we'd find that we get the answer 1225 again. Part B, again, maybe it's easier to simplify this, right? Because 24 divided by negative 6 is negative 4. And we put that to the power 4. So negative 4 to the power 4 is 256, right? Or maybe you can somehow do 24 to the power 4, and you can divide that by negative 6 to the power 4, right? So you could write this as the kind of expanded power inside of your quotient, okay? So I'm not saying that this is always the best way to do these questions, but depending on how you think about a question and how the question's presented, and whether we're talking about possibly throwing in letters like X and stuff, and knowing how these things expand is super, super, super important. Let's try a couple more of these and just, again, look at what the question's asking me to do and how it might be easier to do it one way versus another. So with question A here, I have 3 squared times 3 to the 3, and then that whole thing is being put to the power 3. So again, what I could do is I could work inside my bracket outwards by using my order of operations, or I can apply my new rule. So because both of these terms are being multiplied and they're being put to the power 3, I could put each of these to the power 3. So this is 3 squared to the power 3 times 3 to the 3 to the power 3. And then we could do the same thing over here. So this is 4 cubed squared times 4 squared squared. And then again, because we have a power to a power, we can multiply them. So 2 times 3 is 6, and 3 times 3 is 9, and then 4 to the power of 3 times 2 is 6, and 4 to the power of 2 times 2 is 4. And because we now have a product of two powers, we can add their exponents. So this is 3 to the 15 minus 4 to the 10. Now, I don't expect anybody to do 3 to the 15 and 4 to the 10 in their heads. So this, at this point, is where we should be grabbing our calculators and typing those out. So 3 to the power of 15 minus 4 to the power of 10. And we get 13,331. Big number, not one that I expect you to do in your head, but just see kind of how this process works. I'm going to skip B for a second and just look at question C. So this is where it's really important that we are kind of taking the whole question in, not just starting from, oh, I see this is a cube and this is the fourth, and then kind of go from there, but realize kind of what the end result is supposed to look like. Because a lot of the times we can spend way too much work doing a question when the answer is actually supposed to be quite simple. I don't know necessarily right off my head what -5 to the power 3 is, or -5 to the power 4 is, and I don't know necessarily what to do the addition is. But what I do know, that no matter what's inside this bracket, I recognize that it's being put to the power 0. So right away, without doing any more work, I actually already know the answer, because anything put to the power 0 is 1, right? So understanding this is going to help us solve these types of questions. When do we use our power laws or our power exponents? When are they going to make our lives easier, and when are they going to make our lives harder, right? So the more practice we get with this, the better we're going to be able to apply those rules in a way that's going to make our lives make more sense and going to make our questions easier to do. Let's do one more and kind of look at what this question is saying. So simplifying versus evaluating. Understand what that means. So if a question says to simplify, it does not want you to actually give the answer. It just wants you to take these things and make them as easy to work with as possible. If the question says evaluate, at that point, it does want the answer. It wants you to actually take a calculator or do the work and actually show me what the result is. So if I say to simplify, I'm asking you to stop at a certain point. If I say to evaluate, I'm telling you to kind of go past that point and then give me the end result. Simplify usually means use your rules or use your exponent laws wherever you see them. So if I'm looking at a question like this, I see 3 squared times 3. And even though it's not there, I should hopefully know that 3 is actually 3 to the power 1. So how do I use my exponent law? Well, I see two powers with the same base. So what am I going to do with their exponents? I'm going to add them. So this thing is 3 to the 3. Then I see 3 to the 6 divided by 3 to the 5. So again, I see an exponent law here. This is, again, two powers with the same base being divided. So this is 3 to the power 6 divided by 5, which is 1. So if the question says to simplify, I would stop here, because there is no rule that takes powers and adds them together nicely, so there's not much more we can do. But if I were to ask to evaluate, at this point, this is where we're actually taking these answers and we are plugging them into our calculator, or we're doing them in our heads. So 3 to the power 3, so 3 times 3 times 3 is 27, and then 3 to the power 1 is 3, and 27 plus 3 is 30, right? So to simplify, this is where we would stop. To evaluate, right, this is where we would stop. So hopefully we understand what the difference is and what a question might be asking us to do. All right, so that is it for today's video, and actually that is it for powers and exponents. So I hope we all have a better grasp of kind of what we're doing, and we're feeling ready for whatever comes next. I will see you all in the next one.